Today is January 31st, and we are working on Chapter 6 review because this weekend is a Chapter 6 test, and we've talked about that quite a bit. Okay, let me say that again. We've talked about that a tremendous amount, and so hopefully everybody's fully ready and prepared and feels good about that. So let's start looking at the problems people have sent me. This is on page 386, problem number 2. Let's just start at the beginning. I would like everybody to have paper and pencil and write this down. 10x squared y to the 5th minus 5x squared y cubed minus 25 x to the 5th y cubed. Okay. And as often we do, I'm going to pause my screen. I'm going to let you solve it. Now, I know the answer's in the book. I know you've done it as homework, but I'd like everybody just to wake your brain up by writing this down and doing it fresh anyway. Even though you've done it, just write it down fresh and solve the problem. Don't send me your answer. It's going to be too much to type in on this one. Okay. Yeah, send me a chat when you're done. That'd be great. Thank you. Thank you. Okay. I have about half the people done. Thank you, thank you. Anybody stuck? Somebody must be stuck because it got on my homework list. Can I put my screen up? There is one thing about this that feels tricky, and that is that in the middle of it, there's a number 1. But notice if you look at the numbers only, 10, 5, and 25, in my mind, the number 5 pops out. And if I factor out, thank you, no, that's fine. If the number 5 occurs to me that I can pull a 5 out, and when I do, I have a 2 and a 1 and a 5 left over. And matter of fact, since I'm dealing with signs already, I pulled out a positive 5, so it would be a negative 1 and a negative 5 there. Now the negative 1 might be the confusing thing right there in the middle, but if you factor a 5 out, you're going to have something there, right? When I look at my x's, I have x squared, and x to the 5th. The most I have is 2 of them. Okay, I get bad teacher award. I just get, make sure you check your work award. I'm in a y squared. When I take an x squared out of the x squared, it's gone. When I take an x squared out of the x squared, it's gone. When I take an x squared out of the x 5th, I end up with x cubed left. And so everything is going to have the right number of x's in it. And then, of course, I have the y to the 5th, y to the 3rd, y to the 3rd, which tells me I can take out a y to the 3rd. I'll have y squared in the first one and nothing left in the rest of them. So with all the color, it looks a little convoluted. But if you took this equation, and it's not a bad idea to think through it when you do something. And if you took what you have and distributed it, distributed it like that, right? I have 5x squared y cubed times each thing inside. And if I did that, I would turn out to have exactly what I started with, 10 x squared y 5 minus 5x squared y cubed minus 25 x5 y third. And again, we've done a lot of multiplication where we start with this and we come to the answer. Chapter 6 is all about going and making sure you can go the other direction. Okay? The 1, does that confuse anybody? To have that -1 in the middle? It's like it's all factored out, it disappeared. Yeah, but if you distribute it back in, you've got to have it there. You've got to have something there to remind you that it's going to show up if you distribute. Okay? All right. Problem number 8, x squared plus 2x plus 1 minus 4z squared. Okay, so just real quick, everybody type me a quick answer. What's the first thing you're going to look for in this problem? Okay, that's the second thing I would say. Tatiana, what are you going to do first? There you go. Just make it a habit, of course. Yeah. I mean, in some respects, you can glance at it and forget that you're looking for it. But first, right. Yeah, first you're going to look for common factors. Always, please always start with common factors. And in this case, there are none. So then we have 4 terms. Is it going to be a 2-2 or a 3-1? And by 3-1, it might be a 1-3. Am I going to group them into pairs or into a group of 3 and 1? Can you tell by looking? Okay. Yeah. Yeah, I agree. Yeah, good. Everybody's answered so far has said 3 and 1, and I agree. You do have the one thing that could work against that is I do have a difference of squares. But if I factor the blue set and I factor the gray set, one will have x's and one will have z's. I'll have x times x plus 2 plus 1 minus 2z, 1 plus 2z. I don't have anything in common because one set of factors has x's and one has z's. So that's when you say, you know, that tool is a good tool, it's just not helpful in this problem. And everybody that answered recognized that. If you didn't answer and you're not sure how you would know, that'd be one thing to do. Just try it and see. You could try either one. Doesn't hurt to try it. You can see how it goes. But when I look at this, I realize I can factor by putting those 3 together. So I've got you started on that problem. I'd like you to go ahead and solve that problem and send me an answer. When you're all the way finished with it. Good, Tatiana. Yes, Isaac, there's more you can do. So go ahead and take it all the way to the end of the problem. Good, Maggie. So far, so good. Keep going. Yes, Magnus. And Waylon, nice job. Good, Elena. Keep going. Yes, Isaac, nice job. Nick, I sent you a comment. Good, Maggie. Nick, do you know how that changes your answer? Good, Elena. Okay. If you've gone as far as you can go, let me know, and I'll know that you've not sent me an answer, but you're ready to move forward. Okay. Good, Nick. That's it. All right, so on the screen, the x squared plus 2x plus 1, I'm looking for the factors of 1 that add to be 2. That would be 1 times 1. The factors are the same, they're both positive, so that factors to x plus 1 times x plus 1. And I have from that line 2. Then I made it x plus 1 squared, and now you have to recognize that you have a difference of squares. When you have a difference of squares, you put the first term in the front, you put the square root of the second term. Now 4z squared is 2z squared. That goes in the back. And the formula for the difference of squares says you're going to add it and you're going to subtract it. X plus 1 plus 2z, x plus 1 minus 2z. Okay, now let me pause. Some of you were lost, had gone as far as you could. Does that make sense to you now? Is that fill in that whatever gap that is at that one moment when you didn't know what to do? Now you know? Or is there still a question? A couple of you were saying you needed, okay. Okay. Now, I did have an overachiever try to go further because in the last section we often had to solve. And so one student, not calling names, acted like there was a 0 there, so you could solve and say x plus 1 plus 2z equals 0. So the answer I got was -1 minus 2z and -1 plus 2z. The problem is there's not an equal sign in the problem, so you can't solve. You stop at factors. Your final answer is going to be the factored form, which means everything is in parentheses. You have to know when to stop. Okay, the reason you can't go on is simple. There's no equal sign. No, I didn't call you out. Nick, you called yourself out. No, Nick's doing great. But that's a very common thing. That's why I made a big deal about it. You've heard me make a big deal about it, right? We had, we solve equations, we simplify expressions. No worries. Today's the day to make that mistake. Test, not so much. All right, number 13. I'm counting on you all. 27 x to the 6th plus 1. Yeesh, that's rough. You have, I will tell you that this is kind of incognito. It's hiding a little bit in its own corner. This is a sum of cubes. And I would like you to solve it using the sum of cubes formula. And send me your answer. No, well, no, a cube, not a perfect square, it's a cube. Okay. You have to think about this one. Yes, Isaac, I like your answer. Sarah, check. What? No, yeah, check that, Sarah. And yes, Tatiana, that's right formula. Good, Waylon. Now, if you're stuck at all, send me this. If I'm telling you this is the sum of cubes, that means you're going to have a perfect cube in front, and you're going to add another number that's a perfect cube. Send me, if you're stuck and need a little nudge, tell me what you think the cube, we call the sum of cubes a cubed plus b cubed. What is a? What is b? Jack, I like everything except the middle term in your second factor. Nick. And Nick's going on 2 hours of sleep, so you have to decide, did he do it right or not do it right? Okay, good. Jack, yes, that's your first term. Okay, I have some crazy answers. I have some good answers. It is a bit tricky. Everybody okay if I show my screen? All right. First thing you need to do, of course, is realize sum of cubes has a formula. So this is your first thing to do. In a problem that feels tricky, I would suggest that the second thing you do is rewrite it as a sum of cubes. This is cubed, and I'm going to add this, which is cubed. To factor it, and I should have started with this, if you have a cubed, okay, let me fix this a second. You're starting with a to the third plus b to the third. Something is being cubed and something else is being cubed. Okay, and what I'm cubing is 3x squared, so that's my a value, because 3x squared cubed, remember, 3 times 3 times 3 is 27, and if you have a power of a power, you multiply the exponents. They did give you an easy second term. It's just 1. Okay? When you fill it in, a plus b becomes 3x squared plus 1. Then you have to square a to get 9x4 minus the product of the two, a times b is 3x squared, plus the square of the second one, plus 1. So this is the answer that I'm looking for. And you're never going to get there without the formula. Correct. You have to know the formula. I don't give it to you. You have to know it. You have to recognize it. And then you have to fill it in correctly. And again, if it's simple, if it's simply x to the third minus 8, well, you might look at that and say, okay, I'm going to have x minus 2, x squared plus 2x plus 4, and you might not have to write down an intermediate step. Maybe. But again, here's the deal, right? Do I have to show my work on that? I don't know, do you? If you can write down straight from one to the next, and you get it exactly right, that's fine. If you don't, it might be a decent idea to write down x cubed minus 2 cubed, a equals x, b equals 2, write the formula down, and then fill in the formula in. Okay. Again, the bad teacher award. Hang on a second. I'll get my signs right. I always check myself. I get the numbers right, but I can get those signs backwards like nobody's business. Right? So when I fill it all in, I get the same answer, right? But how much do you need to write down? The answer is as much as it takes to get a right answer. You know, it's kind of important to get a good answer. It's a really good skill. Okay. If you're not solid with those, here's a good thing for a wise, honest, responsible, mature student who says, you know, I didn't get that. I'm not so sure that I'm going to be good at those yet. I think I need to do some more work on it. Then you could turn back to page 385, which is in this chapter review. And I can see number 30, 31, 32, 33. Anything that's a binomial, right? If it's a binomial and there's nothing to factor out, it's either the difference of cubes, sum of cubes, difference of squares, sum of squares. Don't forget sum of squares is prime, right? And you can solve that. And then don't forget too, if you solve it and you can keep on factoring, by golly, keep factoring. Okay, work on that. If this exposes something that you're not good at yet, then that's why we're doing it, so you can find out what to work on. Number 18, 5m times m minus 1 equals 2 times 1 minus m. Boy, I can think of a couple of ways to work this one. There's a just get in there and do the math and gut it out way, and there's a really easy, simple, mathematically beautiful way. I'm going to pause my screen, work it both ways. I'd like you to work it. Send me your answer. And then this is a solve. Yes, good, Waylon. Right, this one you can solve because there's an equal sign. So you're not finished until you have m equals. So if you're having trouble starting, you can just, probably the way that would make most sense to you would be to multiply everything out, get it all equal to 0, factor and solve, right? And maybe the first thing you do, get everything equal to 0, and then you just need to get it to in factored form. Yes, nice. Good. That'd be perfect, Tatiana. I'm going to turn my screen on. Good. Excellent. Anybody need a little bit more time? Excellent. Excellent. Yes, there's just a little bit more solving after that. I'm going to wait just a moment. Excellent. I'm going to turn my screen on. If you're still finishing up, that's perfectly fine. Two ways to do this. Both are fine. On the right side, I kind of did what I think might be the easiest way to do it because it's the most common thing to do. Okay, you guys give me one moment. Okay, sorry. Okay. The right side is kind of how I would expect it to be the most, maybe the most straightforward way. If you say, you know what, don't do anything fancy, signs confuse me, let me just go the straightforward path, I would say that's a very straightforward path on the right side. I distributed. Uh, 5m times each of them, 2 times each of them. I set equal to 0. I factored. And I solved. And so it's pretty straightforward, really. And the key thing is, let me write this down in a bold color. Everybody listen carefully. This is a quiz problem that people had a problem with. And that is this. You must have factors equal to 0 in order to solve. So getting it set equal to 0 is very important, hugely important. And that was something people didn't do correctly on the quiz a few times. On the left side, I did a little bit of a nifty way, a little less work. You just have to be a little more thinking about what you have. I moved the 2 over. I got it set equal to 0 first. I guess that's actually in that step. And then I noticed, remember we spent time on this the other day? I have m minus 1 and 1 minus m. I could make those the same if I change one of the signs. So this minus sign in the middle became a plus sign, and the 1 minus m became m minus 1. And then I factored out an m minus 1 and had 5m plus 2, which I solved to get, shockingly, the exact same answer as I got when I worked it on the right side. I preferred in this set notation. This is preferred form. This is also correct. Okay. They set you up to notice that you could do it in kind of an easier way. Do you see what I'm saying? The left side is easier but harder. It's easier to do but harder to see. The right side takes a little more work, but it's pretty obvious what to do. And isn't that interesting how we can look at a math problem and do it very different ways, really, to get the same answer? How's everybody? Good and groovy? Okay. Number 19. The area of a triangle shown is 40. Find the length and width of the rectangle. Okay, so it draws it for you. It doesn't even give you it in words. It just flat out says, look, here it is. This side is 2x plus 3. This side is x plus 7. The area is 40 square inches. I suggest that you always start with a formula. The area of a rectangle is the length times the width. That means that 40 is x plus 7 times 2x plus 3. This is a very good example of when you cannot just say, okay, factors are equal to 40, so one of them's 40. You don't know anything about those. One of them may not be 40. 40 times 1 is possible, sort of, not really. It doesn't fit the criteria. So what we have to do, first off, get it set equal to 0. Second off, we're going to simplify the polynomial. Third thing we're going to do is factor. Then we're going to solve. Then we're going to answer. Can't forget any of those. To get it equal to 0, I'm going to have x plus 7 times 2x plus 3 minus 40 equals 0. Now we're going to FOIL this part. 2x squared plus 3x plus 14x plus 21 minus 40 is 0. There's no way to get around it. You have to FOIL 2x squared, 17x. Okay, if I have 21 and I take away 40, I have a negative 19. So now this step was here when I set it equal to 0. Once I get down to here, I have a simplified polynomial. It is now simplified. Now I'm going to factor. Here's something that's kind of convenient. 2 has to be 2x and x, and 19 has to be 1 and 19. I don't want to multiply the 19 by the 2, so I'm going to put the 19 over here. Signs are different. The base one's positive. It's going to go like that. It may take you more time than it took me. I'd like to think that, 100 years of doing math might make me a little quicker at it. It sure hadn't made me perfect at it, so at least maybe I can be quicker at it. Then, once I've factored it, now I'm going to solve it. 2x plus 19 equals 0. X minus 1 equals 0. So 2x equals a negative 19, and x is a negative 19 over 2, or x equals 1. I have now solved my equation. I have two answers, just like I thought I would, right? The value of x includes a set of numbers, negative 19 over 2 and 1. But I haven't answered my question yet. Number 19, find the length and the width of the rectangle. I can't have a negative side to a triangle or to a rectangle, negative length. So if x is a negative 19 over 2, if I have x plus 7, that's a negative 19 over 2 plus 14 over 2. That's going to give me a negative 4 over 2 or a negative 2, and that's going to tell me that's not going to work. Right? I can't have a negative side. So maybe you need to try it, maybe you don't. If you were to try it, you need to come up with an answer and realize, okay, well, that mathematically works, but for my particular problem, it's not going to work. So if I say, well, my other option is that x could be 1, then the length is x plus 7, that's 8. The width is 2 times 1, that's 2, plus 3, that's 5. And what I've actually done is just solve the problem. Because the length is 8 inches, the width is 5 inches, that gives me an area of 40. And the length plus 7, if the length is x plus 7 and the width is 2x plus 3, that fits the criteria. Notice that 1 is not part of the sides. And of course, notice that I answer the question, find the length and the width, and I gave it in units. Okay? if you're going to be successful in this test, if you're going to make an A, you're going to have to be able to do the word problems. Because there's a couple of word problems, and there are enough points. If you skip them, you're definitely not going to make an A. And if you don't do decent on them, you're probably not going to make an A. Whatever. Not totally true, but it's there. Number 20. A ball is projected upward from ground level. After t seconds, its height in feet is a function defined by this. F of t equals negative 16t squared plus 96t. After how many seconds will it reach a height of 128 feet? How many seconds until the height is 128 feet? Or you have to read and understand, it's always this way. You don't have to learn 35 different methods. It's always this way. The height is defined by the function. First thing you need to know, the height is given by the function, by f of t. So what we're saying is this. This is a function. Let's just do this. This is my function machine. If you tell me a number of seconds, that's what t is. What comes out of the function machine is the height of the projectile. Okay, how high is it now? Well, how many seconds have you been in, right? If you have 0 seconds, when it's time for liftoff, you'll have 0 plus 0, that height is 0 feet. I put in a 0, I got out a 0. What in the problem helps us know that that makes sense? What does the problem say that makes us say, oh yeah, of course? This is one of those really great problems where it's so little math involved and so much understanding involved that I love it. No. Question is very simple. No. You're making it way too hard. I can read the problem and tell you that if I put in 0 seconds, I'm going to get a height of 0, because what does it say in the problem? Like word for word in the problem. A ball is projected upward from what does it say? A ball is projected upward from, good, Isaac, from ground level. What height is ground level? What we're saying is, remember we did a problem in class where you were 80 feet off the ground, but if you project it from ground level, then at time t equals 0, your height is 0. Well, I'm not surprised by that because I took off from ground level. So how many seconds? That means I'm going to find t until the height is 128. What they're telling me is I want to know the height coming out is 128. What did I have to put into my equation to get 128? So let me change colors and solve that. I know that the height is 128. What I don't know is t. So this is my equation to find t. I know everything else. I know the height. Remember, the height is given by f of t. The function gives me the height. So 128 is a height. I'm going to set it equal to the function. And now I'm going to solve. Same thing as before. I've got to set it equal to 0. Think I'll move the 16t squared and the minus 96t over so that I have it positive. I'm going to make a wild guess that everything's going to be divisible by 16. That's going to be 8. And you can at any time pick up a handy dandy calculator and check and make sure that that works. I'm sure that it does, but I'm just going to make sure I didn't do something dumb. Yep. Factor out the 16. Of course, you can factor it like this and have a whole bunch of boxes. 1 and 16, 2 and 8, 4 and 4, and however many there are for 128. But if you factor out the 16, you have a very easy question. The factors of 8 that add to be 6, that would be 4 times 2. The signs are the same, they're both negative. I'm going to solve. If t minus 4 equals 0 and t minus 2 equals 0, then t equals 4 and t equals 2. Wait just a cotton picking minute. How did I get 2 answers? Logic, tell me how. Maybe the words to a song would be a good way to explain it. Good point. There's a t squared in the problem, so I expect 2 solutions, true. I'm thinking more in a very practical way. There you go, Isaac. Isaac's singing my song. What's happening, remember my lovely little rocket, let's say that this is 128 feet up, right? It is, when time is 2 seconds, it's at 128 feet. What happens at 4 seconds? The song is, what goes up must come down. Spin and wheel, round and round. It's really old. It's like older than, it was old when I was a kid. Okay, so it went up and passed 128 feet at 2 seconds, and then it got to the top and it started coming back down. And on the way down, it had to be 128 seconds. I think I said it wrong. Had to be 128 seconds again on the way down, right? Every height that it is, it happens twice, except there's this one magic height right here. That height, it's only that height once. Does that make sense? There are more projectile problems on page 385. There's at least one more. That it is 53, 54, 55. There's more in chapter or section 6.5 that we did. Okay. You just have to understand that the height, very literally, is equal to the function. So when it gives you a height, you can substitute that in for the function. That's what it means when it says the height is given by the function. Okay? All right, so that's all the questions that I had given to me from chapter 6 review. Ooh, and now would be a great time for me to change to my bummer. Okay, I'm in my chapter 7. That's okay. It's just not going to be perfect. I like to be perfect. Very often it doesn't work out for me to be perfect. So I could actually cut and paste them. I might do that later. I'm not going to take time for it now. We're going to move on to chapter 7.2. We've already done 7.1, remember? 7.2 is the next topic for us to go over. And I'm going to tell you now, I need your full attention. We need to make sure that we're ready for this. It's nothing you haven't done in the 4th grade, but it looks weird to our eyes. And that is, in 7.1, we simplified rational expressions. We also multiplied and divided rational expressions. In 7.2, we're going to do the addition and subtraction. Now, if I ask you to find 3 over 4 times 5 over 6, can you tell me your answer? What is 3 over 4 times 5 over 6? I'm not seeing the right answer yet. Oh, there you go. Good, Tatiana. Okay, y'all are making me a little nervous. Multiplying fractions, how does it work? There you go, Lydia. Oh, I see. Never mind. Good, good, good. I wasn't simplifying. I was just multiplying, and all you were assuming the simplified answer, and I was getting myself confused. I'm like, what is going on? Okay, good, good. Two options. 15 over 24 is correct. It's not simplified. Sorry, I'm with it now. 6 is 2 times 3, and so I could cancel the 3's, and I could go straight to having 5 over 8, or I could get 15 24ths and get 5 over 8. Either you reduce by 3 before you multiply, or you reduce by 3 after you multiply. Sorry, I was thinking I was giving you one you couldn't reduce, and I wasn't. Okay? Multiplying is simple. You just multiply, if you have A over B times C over D, it's simply going to be AC over BD. You have nothing to do. It's wonderful, right? Yes, Elena's right. It's one of the number one rules to simplify fractions. I just goofed. Okay, but if we're going to add fractions today, 3 over 4 plus 5 over 6. Okay, I'm going to turn off my screen so I can actually do it, not make a mistake. I would like you to add those fractions for me. You can leave it in fraction form. You don't have to do a mixed number. Good, Isaac. Good. Tatiana, Elena, everybody's got it. Nice job. Yeah, good, Maggie. Lydia and Lauren, very nice. Okay, so I think we basically, right, we know how to do this. It's all good. You can look at 3/4 and 5/6, and you can come up with the fact that the denominator has to be 12. And so to make 4 into 12, you multiply top and bottom by 3. That gives you 9/12. It's an equivalent fraction, right? I didn't change anything. I didn't change the value. I just gave it a nickname. And for the other one, I have to multiply it by 2 over 2. That gives me 10/12. Once I do that, remember the denominator is going to stay at 12, and I have 19 for a numerator. Okay, so I'm convinced, you all have convinced me, we've got a good start on adding fractions. What if I said 1 over 60 add 1 over 126? Kind of talk to me. We know we're going to add finding common denominators, right? Why does this one make us a little bit not excited? What is a common denominator? Is it obvious to you? I mean, the last time you could look at 4 and 6 and say, oh, 12 will work. But this one is a little more complicated. Agree? So here's the thing. And you've heard me say this before, you know, math is intuitive, right? This problem, you don't really have to know 3/4 plus 5/6. You don't really have to know a lot about math to solve it. I mean, about how to find a common factor, common denominator, because, you know, 4 and 6 become 12. It's kind of intuitive almost, right? And you can count by 6s. 6, 12, hey, 12 works. You count by 4s. 4, 8, 12, hey, that works. And you're there in the second or third option. It's really very simple. What I need you to learn first with numbers is how to find a common denominator if it's not obvious. Okay, so I'm going to kind of do the long, thorough method. There will be a little bit of things you can maybe shorten a little bit as you go. Okay. I don't even know the answer. Probably so, Isaac. I haven't done this one. I just wrote it down in my book to do. 60, when I try to find the factors of things, I say 60 is 2 times 30, and 30 is 2 times 15, and 15 is 3 times 5. So I would call 60 2 times 2 times 3 times 5. I have factored it all the way down. Then I have 126. 126 is 2 times 63. 63 is 3 times 21. See, when I can't take a 2 out of it, I do a 3. And then I have 3 times 7. So this is 2 times 3 times 3 times 7. Now, this will always work, but you don't have to do it this way when you have 4 and 6 for a denominator. But if you get something you don't know, this is a good way to figure it out. All right, check in with me. Are you out there? Everybody in there in the zone with me? Okay, good. Good. Stay with me. To find the common denominator, the least common denominator is going to have every representation. In other words, I have to have a 2 and a 2 and a 3 and a 5. The least common denominator has to have everything in the 60, and then it has to have everything in the 126. I already have a 2, so that's good. I don't have to put it down again. I already have a 3. That's good. But I need another 3, and I don't have one, so I'm going to add it in here. And I need a 7, and I don't have it, so I'm going to add it there. Whatever this is, that number is my common denominator. Now, for the 60, I have 2, 2, 3, 5. I'm missing the 21, 7 times 3. So I'm going to multiply the top and bottom by 21, because the denominator already has 2 times 2 times 3 times 5. What I'm missing in my denominator is the 3 times 7, or the 21. For the 126, I have the 2 times 3, 2 times 3 times 3 times 7. What am I missing in this fraction for a common denominator? Right. I have an extra 2, and I have a 5 that are not represented, so I'd have to multiply this one by 10 and 10 so that I'd have another 2 and another 5 in the denominator, because that's what makes this into my common denominator. You see, both of them were missing something. This one was missing a 3 and 7. The right one was missing a 2 and 5. So I multiply by 10 over 10, and that means my new fractions with a common denominator will be 21 over, okay, well, what is that? Well, it's going to be 1,260. Try it and see. You'll find out that's true. Plus 10 over 1,260, that's equal to 31 over 1,260. So this is our answer in simplest form with the first common denominator I could come up with. There's nothing about that problem that you don't already know from the other problem, from the denominator 4 and 6, except that it's just harder to find a denominator when the denominator is 1,260. Now, when we do it with algebra, it's going to feel a little easier than that. Just because we're not dealing with big numbers, we just have factors. But I want to have this page in your notebook at the very least so you can refer back to it, because what's really, really important for you is to recognize that 2 times 2 times 3 times 5 leaves me with needing the 21. And the other set of factors, which is 2 times 3 times 3 times 7, leaves me needing 2 times 5, so I multiply top and bottom by 10. You have to be able to be okay with that in order to really see and solve the problems in 7.2. Okay, so yikes. Let's talk about some problems from 7.2. Let's go to, let's just start with number 4. Paper and pencil, everybody ready to work with me? 12t over 5 plus s over 5. Fast finger typing, send me your answer. Careful, left something out. Good. Think about what happens. Good. How do you add fractions? Nothing changes. We just have this kind of weirdness on top. Have 2 excellent answers. Which means I have 7 non-answers. Are you stuck? No, you just do the top one. The second letter, the second fraction is s over 5. Good, Elena. Magnus, check yours. Yeah, and Maggie, you're right except for that. Good, Lauren. What happens when you add 3/5 plus 4/5? You get 7/5. What happens when you add 12t over 5 plus s over 5? 12t plus s over 5. Right? It's all it is. You're just adding fractions. If the denominator is the same, you are good to go groovy. It is nice. You don't have to do anything else. Okay? Even, let's look at number 10. 10 says 6y plus 12 over 4y plus 3 plus 2y minus 6 over 4y plus 3. I would like you to solve that and send me your answer. And I'll tell you, they're a little bit sneaky. Yes, you can. No, check that one. Good, but you're not finished. What else can you do to that? Good, Maggie. Now you can do one more step. Good, Elena. Excellent. You see, we're never going to leave things very far behind. Okay, our last couple of answers in are not correct. Magnus, you're good so far. Keep going. All right, I'm going to put my answer up. Okay. Okay, now there's not an equal sign in the problem. So we start with this. I put equal. We're renaming it, right? When I combined, I have common denominators. So since I have a common denominator, it just stays that. And I'm going to combine my numerators. 6y plus 12 plus 2y minus 6 gives me 8y plus 6. But wait, we've already finished 7.1, and that means that I can factor the numerator, factor a 2 out, and I get 2 times 4y plus 3. Hey, wait a minute. I've done this before. I have exactly the same factor in the numerator and denominator that will cancel, and my answer is a very happy 2. That's all. I kind of wish that I'd written it going vertically rather than horizontally with all the equal signs, because I'm not solving anything, I'm just rewriting it in different forms. Here's a nickname. Here's a nickname. And here's a nickname. Okay? All right, several of you were in various stages of confusion. Now that you see it, does it make sense? Okay, awesome. So now you know what you're trying to look for. They're going to be sneaky. They're going to be trying to pull stuff off on you. Okay. All right. Now let's do some common denominator type problems that we have to solve and find. Let's start. What time is it? I want to start as easy as we can, but you know me, I don't want to stop with easy problems. I want to do a demonstration of hard ones so that you can have examples of that in your notebook. Number 40, 5 over x plus 9 over 4x. Fast finger typing, tell me the common denominator of this problem. Good. Okay, so Tatiana, you're right. Now go ahead and work it. Maggie, you're right. Go ahead and work it. So, good, Sarah. Keep going. So, Lydia, what you sent me is what they already have in common. Remember, the common denominator is going to have to be more than that so that you can make everything become that. Lauren, you're good. Okay, good. Got a couple answers. Both are correct. Nice job. Good, Elena. Yeah, good. Haven't seen anything wrong in the chat window for a while. Good, Nick. So the common denominator, remember, it would be kind of like if I wrote this. The denominator of the first one, it has an x in it. That's the only factor it has. This one has 4 times x. Well, I already have the x, so I don't have to repeat it, but I need to have a 4. So the common denominator is 4x. Sometimes it is one of the numbers themselves, right? Sometimes we add 1/2 plus 1/6, and you say, well, the common denominator is 6. So I'm going to do 3 over 3, and I'll have 3 over 6 plus 1 over 6, which is 4 over 6, which can be reduced. We always reduce, always reduce, always reduce at the end. Okay, so in this case, the 4x is the common denominator because the 4x already has an x in it, but I had to make this one 4x by multiplying top and bottom by 4 over 4. So that gives me 20 over 4x plus 9 over 4x. That's 29 over 4x, and that does not reduce. That's your final answer. It's just going to take practice, practice, and practice, and practice to get your head wrapped around how to do it with letters. It just makes your head spin a little bit. That's why we do this in high school, not in 4th grade. It's abstract. It's the same skill you learned in 4th grade, but we are requiring you to use your big brain that thinks abstractly to solve the problem. Okay, and so we could do, I would do this. I want to have plenty of time to work examples. I want to remind you that the book, I like this book. In the book, there are examples. And so I want to move on and walk you through some of the harder ones because I don't want you to only see the easy ones with me, but you can look through the examples and they have very good color-coded writing and explanations, and don't forget this, and here's why I did that, and arrows that point. It's really, really helpful. Okay, so use those two if you get stuck on something, but use what I'm doing, use what they're doing. Don't forget about the book examples. All right, so number 50 is a good one. Let's talk about that. 3 over x minus 3, that's a 3, minus 1 over x. Okay. If you talk about factoring the denominators, both of these denominators are fully factored. This is simply x minus 3, and the other one is simply x. Remember, x minus 3 is a factor. You can't just say, oh, that's an x. It's not an x, it's an x minus 3. This is most similar to saying 1/5 minus 1/6. The common denominator is going to be the product of the two of them. 5 times 6. They have nothing in common. Okay? So for this problem, the common denominator is going to be the product of them. So I need to multiply this first fraction by x over x, and the second fraction by x minus 3 over x minus 3. Because my common denominator will be x times x minus 3. Okay? You have to think of it abstractly. And then, by the way, this is not new. We've done the same thing in numbers, where we just say this is 6 over 6 and this is times 5 over 5, so it's 6 minus 5 over 30. We do that. Okay, we've done it before with numbers. It's just this is what it looks like with variables. And then, but wait, there's more. Okay, on this side, when I multiply the numerator together, I get, of course, 3x. On the other side, when I multiply this together, I get x minus 3. But don't forget, you have to subtract all of it. You cannot forget that there's a parentheses around that. You have to subtract x minus 3. So I'm going to deal with my numerator. I have 3x minus x plus 3 over, okay, I'm going to tell you a little life hack. Sometimes I don't want to write the entire denominator all the time. I just put CD, common denominator. Sometimes it gets long and convoluted. And then at the end of the problem, I'm going to write the denominator at n. But if you don't want to write it down every time, especially when it gets long, I'm okay with that. Just make yourself a note that the common denominator is down there, just kind of carrying along. So 3x minus x is 2x plus 3. That's in simplest form, so I'm going to put my common denominator back in the problem. Nothing else can be factored. Nothing else can be simplified. Everything is finished, and I have a common denominator. Could I cross out x minus 3? Up here, you mean, I assume? Right here? Okay. If you think about that, okay, try throwing just random numbers. It doesn't have to work. This is 10 minus 8, or minus 5, call it, over 3 times 5. Can I cancel my, because again, I have a number minus a number on top, and I have something times something on bottom, and the second one, and both of them are the same. Can I just cancel out the 5? Is that 10 over 3? Yeah, can't do it because, why can I not cancel it? Because there's subtraction. You only cancel if everything is being multiplied, right? Now if it's 3x times x minus 3 over x times x minus 3, absolutely, cancel away. It's all multiplication. Matter of fact, let's cancel the x's. That's equal to 3, right? But you cannot cancel if you're not multiplying. And x minus 3 is being subtracted. Okay, I'm losing all my stuff. X minus 3 is being subtracted from 3x, so it cannot be canceled. Okay, I think it's a great thing to just over to the side of your paper think, okay, can I do that? I don't know. Write it down, see. I didn't have to have any particular numbers. I just made the second number, the subtracted number, and the multiplied by number the same to see, well, can I cancel that out? And clearly it's no, you can't. Okay, so then let's look at, this will be a good one. You'll like this one. Number 56, 3 over 2 minus t plus 1 over t minus 2. What do you think the common denominator is going to be? I agree, Tatiana. How can I make this common denominator? Good. Right. Good, Sarah. Yep. Magnus. Yep. Maggie. Yep. Good, Nick. Good. Yeah, a lot of you are saying it. Excellent. Good job. We've worked hard on this skill. I'm glad to see that it's coming through in your mind and you can understand that this is the same thing as 3 over t minus 2 minus t plus a negative 1 over 2 minus t. We already have a common denominator, right? And so then my common denominator is 2 minus t. My numerator is 3 minus 1. 2 over 2 minus t. Okay, that's a nifty little trick. We've worked on that a lot, right? I mean, we did that a lot the other day. You can change the order as long as you change the sign. So that's a good one to know. All right, so then let's do some of these. Everybody put your wading boots on. We're going to go deep. It's not too deep. You're able, but I just want to warn you. And can I just say this to you also? This is not going to go away. We're in chapter 7.2. We are going to do this and do this and do this. We're going to do bigger problems than this. This is the beginning. Okay? So please don't zone out or assume that you can get by without it. You're really going to have to understand this. And it's really going to take practice. And it will probably take some questions, right? You're going to need to ask me some questions. You're going to do the problem, check in the back of the book, make sure it's exactly right. Okay, step 1, we're going to factor everything. All right, t minus 2 doesn't factor. So I'm just going to write it down in parentheses to know that this is the factor of the first problem. The second one, that does factor. And the third one doesn't factor. All right, maybe it's intuitive and you look at that and you're like, I know what the common denominator is, and maybe it's not. Let me show you how to find the common denominator if you don't know it already. Go over to the side and write down CD. That means common denominator. Put everything in the first fraction in the denominator. Everything there goes in your common denominator. Write that down. Then look at the second fraction. Everything in this denominator has to go in. Well, I've already got the t minus 2, so I don't have to write it down again. It just has to be there, but it's already there, so I'm good. But I don't have a t. I better put a t over here for my common denominator because I need one of those. Then I go to the third fraction and I say all I need is a t, but look, it's already there. Okay, you're done. You've now found the common denominator. It's t minus 2 times t. Let me pause. So far okay? Really, really, really have to know how to do this. Okay, make sure you can find the common denominator. We'll keep practicing. We've got time, a little bit of time, not a lot of time. The next thing I need to do is figure out what has to happen to the first fraction to get the same denominator. See, this is my common denominator, and all I have is a t minus 2. If I want to get a common denominator, I need a t on this fraction as well. And so my first fraction becomes 7t over the common denominator. See my little life hack there? I don't want to write it every time. The second fraction, as it turns out, already has everything I need. T times t minus 2, it's already all there. The third fraction, it needs a t minus 2. Because now the denominator would be t times t minus 2. So far, so good? I would love to have 9 quick answers. It's okay if your answer is no, but I'd love to know that 9 people are paying attention and reasonably okay with what I'm doing. Okay, I'll take 75% at this point. That's good. This is number 64. I mean, by the time you get here, you've done a lot of problems. Okay, all right. I appreciate the honesty. Some of you are a little bit fuzzy. That's okay, right? It's in your notebooks. It's in your recordings. You can work up for a point, and then when you get here, you're like, okay, now I'm going to go back to that. And I hope that it's well stated so that you can get there when you get there. Here's the thing on this problem that is making me twitchy. Because I know that there are some people in this classroom, although I think you're awesome and fabulous, you're going to miss signs on that part of the problem. So let's talk about it. When I combine this into a single fraction with the common denominator, I have 7t minus 6 minus 3 times t minus 2. You have to remember that that's a minus 3 times t minus 2. So 7t minus 6 minus 3t, here we go, ready? Plus 6 over the common denominator. And then I'm going to combine terms. 4t, hey, minus 6 plus 6, poof, that's gone. I'm going to go ahead and put my denominator, t times t minus 2. How many of you think, wait a minute, Mrs. Barnett, you're not through yet? Because I'm not. What can I do still? When you're through, you got your common denominators putting together. I could distribute, but I want to leave it in factored form. The answer stated in factored form is best. Anything cancel? Yeah, notice this is 4 times t, or over t, times t minus 2. This time I can cancel my t's because everything is being multiplied. And that gives me a final answer, simplified, as 4 over t minus 2. Right? Why can the 4 and 2 not cancel? Because look, there's a 4 and a 2. I could cancel that out and put a 2 on the top. How do I know for sure that I can't cancel the 4 and the 2? Maybe you can cancel the 4 and 2. Anybody know? Because the 2 is being subtracted, right? Yeah, but you can't cancel it because you only cancel if your multiplication. See on the left side? 4 times t over t times t minus 2. So everything's being multiplied and the t's will cancel. Now I have 4 over t minus 2. I can't cancel the 2 and the 4 because it's being subtracted, right? You know that, but it's easy to forget, and it's easy to not have it right off the bat. Okay, so I'm going to have time for one more problem. Let's do a fun one. Let's look at number 76. 2 over m squared minus 4m plus 4 plus 3 over m squared plus m minus 6. Guess what we have to do to get a common denominator? You have to guess fast because I'm going to be out of time. What do you always do to get a common denominator? Absolutely, Jack. I have to factor. You see, way back when, in Chapter 6, this little thing was one problem all by itself. But now that I'm in Chapter 7, doing 2 of these only helps me find the common denominator so I can add my fraction, so I can put it together, so I can find a solution. Make no mistake, we are moving on. Okay, so I factored those. m minus 2 times m minus 2 and m minus 2 times m plus 3. I'm going to find my common denominator. I'm going to do that by writing down everything in the first fraction, and I do need 2 of them, m minus 2 times m minus 2. Now I'm going to look at the second fraction. I'm going to write down everything there. But wait, there's already an m minus 2. I don't have to repeat it. But I do need an m plus 3. So look what happens here. It's like saying these two have yet to be multiplied by m plus 3 over m plus 3. Because if I multiplied m minus 2 times m minus 2 times m plus 3, I'd have the whole thing common denominator. Do you see how that works? The second fraction is m minus 2 times m plus 3. What I'm missing is m minus 2. So I'm going to multiply this fraction by m minus 2 over m minus 2, and that will make my denominator in each case exactly what I want. M plus 3 times m minus 2 times m minus 2. M minus 2 times m plus 3 times m minus 2. I have a common denominator. Again, I'm just going to write CD for common denominator right now. At the end of the problem, I'll put it in. I don't want to write it all the time. My paper will look neater if I don't do that all the time. So the numerator has to be multiplied by m plus 3, and the other numerator has to be multiplied by m minus 2. And now, all I have to do is simplify. 2m plus 6 plus 3m minus 6 over the common denominator. When I combine that, I get 5m over m minus 2, m minus 2, m plus 3. Does anything cancel? I'd feed you the answer because I'm about out of time. Nope. I have to cancel everything or nothing. Probably the back of the book would state the answer with an m minus 2 squared as opposed to having it written down twice. My assumption is that the back of the book in simplified form would write that down. Okay, so I strongly urge you to, number one, do really well on your test. Test is your first priority. Get it done. But one of the difficult things about being in the Monday, Wednesday class is if you don't do the test until the deadline on Sunday, you're going to show up on Monday without having done this homework, and I do not want you to show up without doing this homework because it is important to be ready to go on because this is only 7.2 and we are moving on from here. Okay, so however you want to do that, you are wise, honest, responsible, mature students, you can figure it out. You can do the homework first and do the test later. You can do the test on Thursday or Friday and do the homework on Saturday or Friday or Sunday or whatever. But before I see you Monday, you need to finish the test and the homework on 7.2 in order to make sure that you're ready to move on with us on the next thing. Use the recording, especially when you get to the last part of the page. Check the back of the book. You can look at the back of the book and know what the common denominator is. So if you get stuck starting, use the back of the book to help you figure out your common denominator, unless some of it canceled out. Okay, so you can do it. It's going to take some work. I believe in you. I will see you on Monday. Do well on the test. Make me really, really proud. Thanks, guys.